opinions on the use of numerical methods, starting from complete belief that they can solve all the problems we have, and the other is that they prove to be useless for soil classification purposes. In this small talk, in fact, I'm afraid I'm not going to speak 1 hour, maybe I'll be a little bit more brief. I wanted to outline some of the latest achievements in this area, some new paths we found in numerical soil classification, and to discuss the value of these findings. Well, I should start from very general things about soil classification. You definitely know, but anyway, for introductory purposes, maybe it is important to outline them once again. Generally, soil classification has three sources. One of these sources is folk soil knowledge, because you know that soil classification is older than soil science. People were classifying soils long before they created a specific scientific discipline they were dedicated to soils. People were managing soils. People were using soils as constructive materials. People, even earlier, they were even consuming soils to improve their digestion, such as magnetic soils, for example. And some people were using soil for coloring their skin, even. And they classified soil according to these properties. If the soil was edible, if the soil was useful for coloring their face and body, was it good for producing food, and so on. These pragmatic classifications were not much worse than the classifications we have today, in some respect, at least at local level. But also we have another source of soil classification, which is the pedogenetic theory. And the idea that soils should be classified according to our knowledge on their genesis, on their geographical distribution, on our deep knowledge in soils and relations between soil forming factors, soil properties, well, the processes that pedogenetic processes we can observe or model, and external soil functions. And the pedogenetic theory explains us why the soils are different. And that's why we have to pay attention to this theoretical knowledge that may seem useless to some of the practical workers. And the third component is empirical data. The data we receive on soil properties, and some people say that it is more important to know better about soil properties, and we have to forget about soil genesis, and we have to forget about the roots in the folk soil knowledge. And this empirical data may be managed in a specific manner, and then we can divide all the soils in a certain number of classes. That is classification. Well, in conventional soil classifications, well, generally we have several characteristics that are important for understanding the internal organization of soil classification. And we know that there are many soil classifications, and they use different approaches, and they differ exactly in these characteristics, such as the taxonomic structure of the classification, the diagnostics we use for dividing one soil from another, and terminology we use for denominating soils. In most cases, we deal with taxonomic soil classifications, but it is not the only form of organization of knowledge. Taxonomy is more convenient for users. Yes, just because people cannot deal with more than 7 or maybe 10 entities at a time. In fact, 7 is optimal. Well, I remember that our mutual friend Juan Jose Ibanez exactly studied these cognitive issues related to the number of soil taxa we can have on the same level. Okay, anyway, 10 it's okay. More is a little bit more complicated. And that's why it's better to put a taxonomy, a pyramid of knowledge. But it's not the only way, because there are databases. Référentiel méthodologique in France or WRB, they are organized more than like databases than like taxonomies. But in fact, they're not databases. They look like that. But it is another topic. Well, there are also tables. Well, we can make a two-dimensional table, well, like, for example, the system of chemical elements, and use this table as the form of presentation of soil classification. And for example, in this sense, South African classification is one of the examples. In lines, we have the middle soil horizons B, and in the columns we have the organic profile, the topsoil. And the combination of these two components give us a soil profile. Why not? For small groups of data, it is possible to do it. And also we have nominative systems, and most folk soil taxonomies are nominative systems. And well, in many countries there are systems of soil series which are in fact nominative systems. But also we can easily combine these two nominative system with taxonomy, as we have in the United States. We have a combination of table with taxonomic structure, like in South Africa and so on. But it is interesting how people organize the data in different way. Diagnostics. There are two different approaches. One of them is quantitative and the other is qualitative. In fact, there are not two mutually exclusive approaches, because we can see also a combination of these two, and the next slide will see some examples. And finally, terminology. In soil science, we have traditional terminology. For example, the well-known soil names like Chernozem, Podzol, they were used from early time, and then by folk soil taxonomies, by their farmers, and then they were just introduced to the scientific literature by early soil researchers in Russian Empire. And also we have pseudo-traditional terminology, because, well, for example, we have a folk named Podzol, that means ash underneath. But also we have such terms in Russian classification like Pavel, or that means white underneath. And we have Padbur, which means brown underneath. These names never existed in folk soil taxonomies, but the scientists proposed these terms that resembled the traditional terminology. And then we have artificial terminology, which it was the invention of Guy Smith and his team when soil taxonomy was created, and it was a novel approach. Some people were just joking about it, that these strange words like Alice in Wonderland or something like that. But in fact, it was a good invention, a good idea to escape from misunderstanding, because the same term was used in different schools for completely different soils. And now it's one of the most productive approaches. And sometimes we have a combination of these two. We have some traditional terms and we have some artificial terms, and WRB is the best example of that. Okay. Well, the limits of soil classes may be different. Well, for example, if we use some quantitative limits, and we say, for example, if the soil has base saturation 24 centimoles per kilogram, then it goes to Lewis soils. If you have less, it has Lixi soils. And it is a very strict limit. And we put these limits in many dimensions because we use various multiple properties to limit one soil from others. This is an interesting topic because, well, it is very easy to allocate a soil profile, a particular soil profile in this case, but it is a little bit complicated when we have real soil combination with very similar soil properties, but exactly on the limit of the classes. It is very difficult to explain why exactly this limit was used. We have very small variation, but we can, but the soils can split into two classes. And anyway, and even in this case, we still have some centroids that represent the most typical properties. These centroids are not used for classification properties, for diagnostics of soils, but anyway, these centroids definitely exist, because for every soil class we have some core properties that are very typical, and we have some marginal properties that are on the limit with another class. And the other approach, when we have centroids with very strict, they may have strict limits, or they may be even not established. Centroid may be established not by the formal limits, but by the description of the central image. It is a very common thing in, for example, in biology. In biology, they do not use strict limits. For example, they do not say, well, if we have the length of the diameter of a flower more than 10 centimeters, there is another class. No, they never do it. They have a description of the central image, and then it serves as a centroid. And any centroid also have some buffer zone around it, and the profiles that fit in these zone of around the centroids, these profiles should be classified in the same class, in the same group. Okay. At some stage of the development of soil science, the classifiers decided that they can use some numerical information for classifying soils. They considered that if we put some soils in the multidimensional space of properties, we can find distinct difference between different soil classes. For example, if we take podzol and the chernozem for two contrasting soils and put all their properties, such as acidity, organic matter content, the composition of organic matter, the bulk chemical composition, exchangeable base, etc., etc., etc. Of course, we will find that these two soils stand very far one from another. And the early studies, in fact, they were very optimistic. In the early studies, they believed that they only have to find a proper method of mathematical management to classify all the soils. Alex McBratney says that the first attempts to classify soils numerically, they started exactly when the first computers appeared, because before that the calculation was a little bit complicated. Nobody tried to find taxonomic distances manually. Well, the first attempt to divide soil groups by calculating the taxonomic distances has been done by Hall and his co-workers and his group in Wisconsin University. Well, it was in early 60s. Well, there was the seminal work by Hall and Hironaka in 1960, and then his co-workers returned several times to this topic. And later, some other approaches to numerical classification have been applied, including, for example, single linkage sort and principal coordinates analysis by Muir and co-workers in Rotterdam, as far as I remember. You understand that it is very difficult to manage data in multidimensional space, and that's why principal coordinates analysis was seemed to be an evident decision. Well, Tsipra et al. Used multivariate statistics. Coventry and Williams used 3D and B-dimensional ordination of properties. Well, Dunning and co-workers used principal component analysis, cluster analysis, discriminant analysis, and the graph theoretical method. You see that some of the methods were repeated, but some of them were used by particular researchers. Well, there was also an attempt to combine different clustering techniques. And not long ago, John Galbraith and co-workers, well, in fact, already long ago, 25 years passed, Galbraith and co-workers tried to allocate the soils in the orders of VSD soil taxonomy using decision trees, which seems to be also a very promising technique. A review of the approaches and methods used for numerical soil classification has been done by Vyacheslav Rashkov, well, ex-director of the Kuchaev Soil Institute, who was in fact one of the first researchers who, in the Soviet Union, who tried to apply numerical methods for classification. He is still active and working on this topic and still producing interesting results. And Alex McBratney, you know, of course, Alex, everybody knows Alex, and he was the pioneer in numerical soil classification, also in more modern time. He brought with him new approaches because while just ordinating soils, well, it was not very productive. We will see what Alex prepared in the last few years, and his approaches definitely deserve serious attention and should be of course given certain attention for everybody who is interested in soil classification. In most studies, we are searching for the taxonomic distances between the existing soil taxa, because we believe that existing soil taxa are natural classes. That, of course, is not completely true, because we discussed previously in the first slides, we discussed the differences between soil classifications, how they organized, how the classes are grouped, divided, how the classification is organized. Is it a taxonomy or it is a database or something else? But in fact, the main question is how we distinguish soil classes, how we form soil classes, how we understand that this is the class, how we finally understand that it is a podzol, this is a chernozem. Why we decided that there are two separate things? Maybe we have to classify them only on the basis of their texture or something else. The idea how to divide the space of the soils in real space into groups has a lot of gestalt, of some in-verbal knowledge to say. When we say, oh yes, this is a separate soil. To a great extent, the idea of soil series was based exactly on that. You come to a new profile and you understand that it is a different soil. And then you make a description and you put it in a database, and then it is another question how to combine them, in what groups. How to find these limits is a big question. And the other approach may be searching for natural clusters of soils in a multidimensional space of properties. Maybe that is a decision. Well, let's have a look. Does it work or it doesn't work at all? Well, one of the recent attempts, yet not finished, is the creation of the IUSS working group, Universal Soil Classification. Well, initially it was headed by John Hempel. Hopefully, sorry, he is not among us. And vice chair was Erika Mikkeli. And initially it was about 20 persons who were discussing and trying to find a way for new decisions for finding natural classes of soils. Different approaches were discussed, and currently I think I don't want to say it for the IUSS working group. I don't know, in fact, what are the new findings of this group, but the lack of publications show that the progress is not as important as it was expected. We tried a couple of years ago. We tried to contribute to their understanding of universal of soil groups in the frames of the universal soil classification, and we compared the properties of chernozomes and chernozome-like soils obtained from 3 national and international soil databases: USDA, National Cooperative Soil Survey, WISE dataset based on WRB, and Soil Geographic Database of Russia. And we used the data for 668 soil profiles of so-called black soils. It is a fashionable expression now because FAO started a project on black soils. Well, it is world network of black soils, and generally we include there very diverse objects, but the core of the concept are Chernozyms and Chernozem-like soils. And the first question was what kind of properties we have to include. In many research works, in many recent research works, people were including selected soil properties from different depth of the same profile. And in the same data set, they used the values, for example, for organic carbon content from all soil horizons, not only from horizons, from the depth. 0, 10, 10, 20, 20, 30, and so on, and so on, and so on, and so on, and from multiple profiles, and then trying to find the distance of these properties from the central point, or the area of the geometric figure they had, and so on, and in this way assessing their diversity of soil properties. I don't know if it was, well, in fact, I do not want to judge it. Well, I think that this approach didn't work, didn't produce much new information. And especially, but it outlined the necessity for some soil properties that may be used for comparing one soil with another. Because you understand that it is difficult. We return back to Podzol in Chernozem. What should we compare? Should we use the data from each soil horizon and compare, for example, the properties in parent material in the sea horizon of Podzol and Chernozem? I am not sure. We have to use other properties. We have to use some other criteria. And it seems that the best criteria are the differences. Well, they should not be just values. There should be the difference in minimum values, upper limits, lower limits, maximum organic carbon concentration, and so on and so on and so on. These properties that reflect some important soil forming processes. It is a very important thing. When we use numerical methods, we have to remember what we measure and what kind of data we are using for mathematical management. And here's the list of some properties we used for comparing soil profiles. And then the methods we used included the taxonomic distances between the selected soil units using R software. The Mahalanobis distance metrics were applied in order to take the covariance into account. And using all this stuff, we compared taxonomic distances between Chernozyms in WRB system, Castanozyms, Firezyms, calcisols, gypsysols, selenets, vertisol, and luisols in the same system, Russian soil classification types, and also corresponding orders and grade groups of the soil taxonomy. And on this graph, we can see how these soils grouped when we use two principal component analysis. And white labels indicate there's great groups of soil taxonomy. Green labels indicate the soils of the Russian soil classification, and WRB reference groups are marked with blue labels. And we see that there is an important difference in the position of most of the three classifications. The analysis of this work indicated that most Chernozomes and Chernozem-like soils had small taxonomic distances, thus forming a distinct cluster. Well, it is one of the aims of these numerical games to find natural clusters, if they exist really. It seems that yes, we can find some natural clusters, but sometimes in some places, in some cases, these clusters do not correspond to our taxonomic groups of other level. And it causes us a big headache, because it means that maybe we have to regroup our soils, and that our classification requires some update. Well, for example, shallow soils and soils with a headpond stayed far from the main cluster. They just were in the other corner. Most soils with clay elevation features differed from the central concept of Chernozomes. That is, for me, it's also very natural, because it is another group of much more leached soils, and they should be different. Chernozem-like compact soils strongly differed from the rest of the black soils clusters. We know that vertisols are not Chernozomes, of course. It is an evident thing, and well, numerical classification confirmed it. There is a distinct geographical bias in the taxonomic distances between the soil extracted from different databases. It means it is not only the difference in the approaches in the laboratory. In fact, the methodology used was the same or almost the same. Well, because we know that WRB manual is very similar to soil taxonomy manuals. And Russian analysis may differ mainly because we have different fine earth criteria. We have fine earth less than 1 millimeter, and the rest of the world use less than 2 millimeters. And really, it really affects the results. Maybe it was one of the sources of the bias. Our Russian database is in better agreement with the WISE database, which includes many profiles from Europe. That is natural, because it means that we have very similar soils, because we're geographically close. The US database reflects the specific features of the environments and soils of the North American continent. Well, I am teaching the soils of the world, the course for bachelor level students, and I have to say there are differences on a continental scale. The soils of different continents, they differ, even when we have similar climatic conditions. Many things differ. Okay. It was one of the examples. Now I want to speak a little bit about the recent publications of Alex McBratney Hayes, one of his followers and students, and his group. In 2017, McBratney proposed a concept of comprehensive soil classification. comprehensive novel soil classification. This soil taxonomy is built by adding taxa from existing taxonomies. They just took, well, soil taxonomy, WRB, Australian soil classification, and New Zealand system. In such a way, they consider that the major part of the world should be covered with these systems. The taxonomy, they believe that the taxonomy reduced the redundancy and is additive and amendable. And this taxonomy allows for hard and fuzzy classification of soil profiles. Well, the figure shows the procedure. They were excluding from the resulting classification, the taxa that were very much similar in properties. When the profiles had the same property, they just excluded, or not excluded, but linked together the names from different classification, not to duplicate them. And then they created a very funny dendrogram. Great groups data filtered to smaller data sets in previous research that was published in 2017. Dendrograms created from smaller data sets and nomenclature, and they created a very original proposal of how to call these soils. A new nomenclature was proposed that is shown on the next figure. These groups in the cut dendrogram at different tiers were named using a hierarchical algorithm. First, a sequence of 18 consonants, B, D, F, G, and so on. It was used to name the soil groups at the first tier. At the second tier, we have to return back, you see, they cut them here. Here is the line for cutting the first tier. Then they used the second tier, and within each group of the first tier, they used also the same consonants. And on the third tier, within the second tier, they also used groups with different consonants. For example, and then they used ozom, the suffix or the root zom, which is земля, earth in Russian, like in Chernozem, Kastanozem. And the combination of these consonants produced such names like, for example, fa de bozom. Because it was on the first tier it was F, and the second tier it was D, and the third tier it was B. A very original approach, and in fact it could be really a very interesting approach. But what was the resulting correlation of these groups with the real existing soil taxa? It seems that at least at tier 1 it was something chaotic. At tier 1 the same group included soils from different parts of the world, formed under completely different conditions, and in places even with some contrasting properties. In some cases, it worked very well. In other cases, there were practically random groups. And this very good attempt of a group of very productive, talented, and very knowledgeable people gave an impression that, in fact, this application of numerical numerical approach was a kind of failure. I don't want to criticize it because it was a great job, very interesting and very illustrative. But it seems that pure numerical approaches is not what we need in soil classification. Humanity has come a long way from fold classification and single soil series to complex hierarchical soil classifications, but these classifications were based on the pedogenetic theories, the Kuchayev's approach. Of course, it was criticized, and it was criticized for good reasons, of course. We know that the use of the concept that factors rule the processes determine the properties. It is a logical chain, but this chain has led many researchers to a deadlock. People were classifying soils under similar factors of soil formation as the same, even if they differed very much in their real properties. Because we know that currently very few soils are completely balanced with current factors of soil formation. Most of the soils on our planet are polygenetic bodies, and they reflect not only current climate, for example, or current vegetation, they reflect all the entire history. Victor Tergulyan said, soil is a memory of the biosphere. And it means that we have to include not only the current processes and current factors, of course, we have to take into account the past cycles of pedogenesis. And it makes direct linkage of soils with the factors, it makes it very poor. But anyway, if we forget about the Tykhachev's theory, I think the use of numerical classifications, numerical approaches may also lead us to a deadlock, another kind of deadlock. Of course, numerical classification presented a certain stage in the development of soil classification. We had to try it. But let us think about our neighbors, about the biologists. Of course, they use mathematical methods, they use clustering, they use cluster analysis, they use other methods of statistical management of data to classify better, mainly microorganisms. Just imagine how numerical approach should work with, for example, with the animals, with mammals. Let us classify the dogs, for example. Would numerical methods indicate us that dogs of different sizes, of different colors, should be the same? I think no. If we have the same weight for all the properties, in this case, we have a great risk that we will separate the classes that are natural. And on the other hand, we can group soils that have completely different origin and they have different external functions. For example, under the same name, we group in some classifications soils with argillic horizon that form under completely different geochemical conditions. for example, strongly alkaline soils and acid soils, and they just appear in the same group. We should not believe that simple data manipulation may replace natural classifications. And if we speak about the future of soil classification, I think that combined hybrid classifications should be maybe a wise decision for the future development. They should combine understanding of soil genesis and quantitative soil properties. Of course, we should base the diagnostics of soils on their objective properties, but the interpretation and grouping should be, of course, based on our understanding. Classification is a mirror of our understanding of the world, and that's why they should be updated from time to time. It is natural. We cannot establish one classification forever. And it means that to improve classification, first of all, we have to improve our understanding, to make it deeper. As for mathematical methods, they are advanced enough to help us in the analysis of soil properties and in the development of our classification constructions. Thank you very much for your attention, and I am ready to answer your questions.
If you have any question? Yes, Dr. Cortes?
Do I sit here or do I go up there?
I
okay?
think so.
Okay, yeah. Hello, Pavel. This is Curtis Bunker. It's very good to see you and hear your presentation. My question has to do with the hybrid between the traditional and the new. It's my impression that the centroid is a statistical numerical technique that is not based on primary rules of statistics, mainly randomness. So the centroid was it's a accuracy assessment. And my question is, if we are going to proceed with the numerical technique, should we start with a clean slate and just randomly put points on the landscape? And if we do that, can we have enough points on the landscape to provide meaning in our understanding of how soils differ? So.
Oh, thank you. Thank you, George. I'm also very glad to see you. And you asked exactly the most important question in the entire stuff, because, of course, the existing of already accepted classes, it makes all the story a little bit out of normal statistics. The ideal thing that we collect, we have some database without pre-existing classes, and we consider all these properties as random. I think it's just impossible. And the main thing is that these properties most probably will give us a more or less uniform distribution. If we use, for example, a global database, just imagine, for example, let us have an ideal situation. We have unlimited number of soil profiles on the Earth, and we have an unlimited number of analyses for all these profiles. And most probably, we will have the entire space of soils more or less uniformly filled with these with the points, with the resulting points in this space of properties. That is my impression. I think that we have differences in soils because we have contrasting conditions in one landscape. If we have all the variability of landscapes, we will have the distribution, the more or less uniform distribution for all the properties. I don't think that we will find clusters. All these clusters appear because of our limited knowledge about soils. Do you agree?
Thank you.
Marco, Dr. Bautista.
¿Puedo en español preguntar? Sí, bien. Bueno, felicidades, Pavel, por tu presentación. Creo que se puede trabajar un poco más numéricamente utilizando otro tipo de técnicas estadísticas. Porque, bueno, usaste ahorita pues la más básica, que es componentes principales, pero pudiéramos usar dentro de la familia de los multivariados el análisis discriminante o usar minería de datos para formar árboles de clasificación. No sé si ponen.
Thank you.
Stop because a translation is needed.
Well, I believe that Francisco proposed to use different mathematical techniques, for example, discriminant analysis or something like that. Well, I agree that we have to play with their mathematical methods. We can use different techniques, but in my opinion, it's not useless, of course. It gives us new information, but it will not help us it cannot replace the understanding of the rules that determine the geographical distribution and pedogenesis. It will not help us to do it. It will help us to put better limits between soil groups. Numerical methods, they work very well for finding exact limits, to make some fuzzy classifications and so on, or more ordered taxonomic structure or something like that. But it is just a tool for determining their archetypes of soils. To find the centroids, we need some conceptual effort. It should be an intellectual effort and not just playing with figures.
Yes, please.
Thank you very much, Pavel. The collection of data in the field is expensive, and if we add this collection the information of all analytical procedures, this hybrid classification will be very expensive and maybe not adequate for instance, for Mexico. What is your opinion?
Well, first, I have to say that we have, of course, Alex McBretney. He wrote also in the conclusion that, of course, this classification is not perfect, mainly because of its incomplete geographical coverage. Because, of course, they need data from Latin America, they need data from Russia, from India, from China, and so on. Many big pieces of the surface of our planet were missing in this classification, and maybe it could be improved because there was another publication by Alex and one of his postgraduate students from Iran, and they tried to apply this classification for Iran. It didn't work because it didn't cover the soils of Iran. They were different. Even in arid Australia, the soils are different from Near East. In this case, of course, it may be improved, and I think maybe it should be also improved and advanced. But I see also another important issue. The thing is that it is still subjective because we have to use correct properties for characterizing soils. If they have the entire set of properties and they will have the same weight for example, the content of organic carbon in the topsoil and for the content of zinc in the parent material, it doesn't work. Of course, it is exaggeration because this classification, of course, did not use the content of microelements. This information is not available for the most for all the soils. But anyway, you understand the point. All the properties of soils are equal, but some are more equal than others.
Two more questions. Pavel?
Dear friend, I think you know very well our soil classification system in Cuba. We have the basis of our soil classification in process of soil formation from sialitization to ferralitization, magnetization, so and soil properties. My question is that it is possible to make a numerical soil classification system with this combination?
Well, first, Alberto, I'm very happy to see you here. Second, yes, I know very well the soil classification of Cuba, including the latest version of the classification. And in fact, I like it very much because it is very logical and it is really including multiple aspects, starting from such things as geology and soil weathering, and also giving some important issues related to soil productivity and so on. And third, yes, I think that you can get some use from the application of numerical methods. Definitely, you will get some use from that.
Another question to Pavel? You have? Bien. I have a comment. Because our main objective of this edition, soil classification Congress, is to increase the communication between the researchers and all the statements to the population. And it's a very hard work. So we need to think that which is the best tools. I'm agree that applying the advances in computer information sciences are very confident now, better than 1 year ago, and the next year should be better. But we need to think also then another question. Soil is a living system, and that's another issue that we need to apply to this kind of concepts in order to run more efficient all these programs. We have physical and chemical properties. But if you think what is happening with another sciences is taking in account the soil as a living system. And also, in order to have a good prediction of what is going to happen now to the 2050 and to the 2100. So that is why this is a very dynamic concept that should be developed. But now we need to work what we have. What do you think, Pavel?
Mostly I support this view. In fact, I see many things in soils are dynamic, and it's normal. It's normal because we live in a dynamic world, yeah? And the thing is that if we want to include some dynamic properties in the classification, I think currently it is not considered, of course. Including, for example, you see, for example, the carbonates that come and with groundwater and then disappear after rain. So pseudomycelium, for example, they are not considered as secondary carbonates at all. Well, on the other hand, we understand, for example, the soils with permafrost. Well, you see, the level of ice, it moves. While in summer it goes down, and in winter the complete soil profile is frozen. We should take it into account, but I don't know how we can include it in soil classification. Maybe we have include some maximum content of salts, for example, or for example, that appear in some years. Or we have to include, for example, the deepest layer that has carbonates, or for example, the upper layer that is has ice for more than 1 month, or something like that. Regime, so what's temperature regime, water regime, the dynamic of salts. Well, they both everything can be included if necessary. But I think that it would be more useful if they include it as annexes to classification. For example, like the mineralogical classes in, like the concept of families, for example, in soil taxonomy. Well, or for example, the use of temperature and moisture regimes in WRB. They are not included in soil classification, but it is noted that we can use these classifications of regimes if necessary, borrowing it from soil taxonomy. Okay.
Thank you. Well, we need to give you our grateful for this great talking today, and my best regards. Now we continue our session with the presentation.